I'm Ted Litovitz. I'm at Catholic University. I've been working in this field of what are the effects of electromagnetic radiation on biologic cells. We've done this for about 15 years. We've been supported by a number of government agencies and one corporation. The question today is very simple. You as legislators are being asked by consumer groups to put in place some legislation. They're concerned. They're worried. The real question is, are they irrational? You cannot start making legislation which limits commerce on the basis of irrational fear. So before you leave this room, you have to make a decision. Is this a reasonable fear on their part? What I'd like to do is to go through the science, my view of the science, because there are other scientists here, but I'll go through my view of the science, and you can make a decision at the end. In general, what you worry about at first is, can an electromagnetic field have any effect at all on your body? The sunlight has an effect on your body, but it's not going to kill you. So just because there's a biologic effect doesn't mean that there's a health hazard. Then, after you find biologic effects in the laboratory, you have to ask the question, are there health effects? First question is, have any electromagnetic field effects been seen for non-thermal radiation? Now, what you're asking, why is he worried about non-thermal? Because the standards that protect you today are based upon the heating of the tissue. That's your total protection. If there's any effect out there that can cause a biologic effect on your tissue that doesn't heat it, if it's at levels well below the energy necessary to raise the temperature several degrees, you have no protection by law. So it's an enormously important issue. Are there any non-thermal effects? Many papers have been reported in which they've seen non-thermal effects below those levels considered safe by the government agencies. For example, the safety standard is 1.6 watts per kilogram for energy coming in, deposited in your head from a cell phone. It's based upon heating. There's a paper showing psychological changes at 0.03, that's much less. Effects on immune system, effects on calcium efflux from cells, induction of DNA damage, stress response, the cells feel stressed. Look at those levels there. Affects the blood-brain barrier, affects calcium in the heart, enhances cell proliferation. The first one's 50 times less than the standard, the second one's 100 times less than the standard, the third 300, etc. You see the numbers below the standard. The real question is, what's protecting you? Now, it could be that these effects are occurring, but they don't mean a thing. They just occur in the laboratory or in some people. So it could be the standards are great. But let's look a little further. If it's so obvious that you can get biologic effects at levels 75,000 times lower than the standard, if you can get biologic effects, why is there controversy? Why doesn't everybody come in and say, oh, thermal standards don't mean a thing? But that isn't true. Not everybody believes. Those who defend the thermal standards defend them honestly. What's one of their arguments? Well, one of their arguments is that a lot of this research is not replicated. There seems to be a great deal of replication in the field, whether you're talking power lines or cell phones. And you do studies in the laboratory, you find replication is a big issue. Let's take a quick aside. Is this replication problem only a property of this junk science called bioelectromagnetic effects? Or is it a general property? The answer is those replication problems occur only in bioelectromagnetic effect. No. Let's take an example. We take an unknown drug X. We study its effect in Norway rats. We ask, are these rats born deformed when this drug is put into them? And we do an experiment. 60% of them are deformed. You never let that on the market. But somebody else does an experiment, and none are deformed. It's a lack of replication. So what do? Today, in the bioelectromagnetic field, if something's not replicated, the answer is the people who got an effect are incompetent. Standard answer. Those who see nothing are competent. Science is divided down the middle. You guys are competent because you don't see a thing. It turns out this experiment was done in one laboratory. And there are two strains of the same rat. There was only a slight genetic difference in the ability to handle the drug. The drug is called thalidomide. And 10,000 kids who were deformed wished that the replication issue had been studied more carefully. We did studies in our lab. We looked at chick embryos and we asked, could a 60 hertz field, 60 hertz electromagnetic field cause abnormalities? We did an experiment, we saw double the abnormality rate. Then we repeated the experiment and we saw nothing. It's very discouraging. We saw nothing. We repeated a third time, but we did these in different flocks. And what we didn't realize at the time, the supplier changed the flocks. But we didn't realize at the time when you change the flocks, you change roosters, you change hens, and something called genetics comes into play. The flocks weren't genetically the same. Depending on the flock, you can get huge deformities in embryos. So there is a genetic basis for lack of replication. You don't simply say the effect is not there if every lab can't replicate it. You do the experiment right to consider all considerations which include genetics. Now, I emphasize lack of replication because that's one of the big arguments that we now have to ask, is anything replicated? And the answer is yes. I'm going to pick one set of experiments because it has a point I want to make today. Both in cell phone frequencies and at 60 hertz ELF, the stress response has been studied. These are cells which appear stressed when these electromagnetic fields are applied. In two universities, two different groups in each university have shown this to be the case for cell phone frequencies. In 4 universities, at 60 hertz, this has been shown to be the case. And what we have found is that every time we see something at cell phone frequency, we see them also at power, 60 hertz power. And we use the data back and forth, one to support the other. So what does it mean that we've induced a stress response? What do you care? Is this just like sunlight? You get a little warm, not a problem. We'll come back to that. But let me summarize the argument. The argument is that your standards are based on only heat can cause damage to you. You need to put your head in the microwave oven. That causes damage. But what we've discovered, and not just my lab, is that there's information sent to a cell. Information which is signal, which turns the cell on and causes it to do something it wouldn't normally do. You don't have to heat it to stimulate it with an electromagnetic field. So, weak non-terminal fields cause an effect. Present-day standards don't take it into account. We have to ask ourselves, if you believe me so far, is this just a laboratory curiosity? Are the results I'm presenting just a laboratory curiosity? Are there any potential adverse effects from either the cell phone or the 60 hertz? Well, here's an example from Professor Henry Lai at the University of Washington, where he looks at DNA. The DNA is clumped in the center there. He puts an electric field on, and if there are breaks in the DNA, little chunks in the DNA, the small little chunks move faster. So that when he puts a field on going in this direction, you can see little tiny chunks here in an exposed field, just a few of them. However, if you expose them to an electromagnetic field, cell phone radiation, you see an enhanced number of DNA breaks in those cells in which the electromagnetic field appeared. Just in June, 2 statements were made that are crucial. For the first time, an international agency has stated, the International Agency on Cancer Research stated, that power frequency magnetic fields are possible carcinogens. That's a strong statement, the word possible. It's very strong because EPA tried to make it for years and was never allowed to. This is a little story here. This statement is based upon research that was just published 4 months ago, in which 10 labs got together on all the 10 epidemiologic studies, which included a study by NIH, which 2 years ago told you, the public, that there was no problem. Published in the New England Journal of Medicine, special editorial saying, this is no problem anymore. 2 years later, quietly, because I didn't notice it in any newspaper, the first one was, everybody realized NIH didn't treat the data properly, and what they found is if you separated out those with slightly higher magnetic fields, you got an excess amount of leukemia in children. Is the public going to trust? If NIH comes out and publishes, we know there's no problem, and 2 years later, quietly, there is a problem. Hardell and Mild just came out with a second paper. The first one was funded by someone here, actually, Carlo. But the second paper, which says that if you use a cell phone for 10 years, you saw a 77% increase in brain tumors on the side of the head where you used a cell phone. What they did for the first time was to separate out heavy users, long-time users, from just anybody who went in and bought a phone at Radio Shack and put them into the epidemiologic study. It takes time for a tumor to develop. So, weak fields cause effects. When are they adverse and when are they beneficial? This is important to me because most of my lab is working on the beneficial effects. These same effects that one might be concerned with when you're around an antenna radiating 10 megawatts, these same fields can be used to treat cancer, if used properly. The same fields that can cause adverse effects can cause good effects. Advil is good for you unless you take 50 a day. Everything's a poison. Spinach is a poison. You can quote me. It's got enough oxalic acid, you take 10 pounds a day and you will be sick. This was first stated in the 15th century. My lab is up to date. Okay, see all these effects? Can we summarize broadly what might be happening? What might connect the fields and potential adverse effects? We know. Remember I showed you a slide about stress. I showed you all those labs that showed stress, that stress cells. Let's see the effect of the stress. These fields can alter the levels of protective proteins in your body. They're known as stress proteins. These protective proteins, in a cell, you have a protein which functions. If a stress comes along, you can cause the protein to be damaged. Because it's damaged, a signal goes out and these protective proteins come along, refold it, and give you a functional protein again. All day long, 24 hours a day, these proteins are protecting you. Now let's see. What would happen if we stress and turn these proteins on? Such as, let's say we just put a field on, which does stress them. we induce stress proteins, and that protects against subsequent stresses. We are using electromagnetic fields to protect against the damage due to a heart attack. As soon as you feel a chest pain, we turn these on for 30 minutes, and we have twice the recovery of our chick embryo hearts. We feel this will be used in the future. The fields are good for you if you get one exposure. But too much, for example, repeated exposure, turns down these protective proteins and increases the damage from subsequent stresses. Repeated exposure to the brain puts you in a condition that if you do have a stroke, you're going to have far more damage if these proteins are reduced in their concentration. Here's the experiment we did. You can tell in a live chick because its blood is red, its heart's beating. You can tell a dead chick embryo because its blood turns blue and its heart's not beating. Hey, it's the kind of simple-minded experiment I like to see. It's alive or it's dead. So we simulated heart attacks, and what we found is, by putting them in argon, in a lack of oxygen, and what we found is that if we gave one 30-minute exposure, we could double our survival rate practically, whether we use 60 hertz ELF or whether we use radio frequency cell phone radiation. 30 minutes of a cell phone radiation on your heart when you feel a heart attack is great for you. Well, let's say you put it on several days. Repeat it. What we discovered was that if you repeat it, you reduce the survival rate of those cells, and when we looked at the stress protein, you reduce the concentration. And this is where the problem lies. If you just simply use some radiation, or if in your case you have a 10 megawatt, if you just lived in your home 1 day a week for 30 minutes, you're in good shape. It's because you want to live in your home every day that you have a problem. So you have to rent an apartment someplace. How can this ionizing radiation increase the probability of cancer? This is just a beautiful graph, which was worked by researchers at NRC and NIH. In your body, every cell in your body, every day, creates reactive oxygen. 100 million reactive oxygen molecules. By the way, you know where it comes from? It comes from you have a habit. The habit is called breathing. And because you breathe, you generate reactive oxygen every day. And 100 million of these reactive oxygen species go after your DNA. If it weren't for defense mechanism, you wouldn't last but a few days after you were born. However, of this 100 million, because of antioxidants, you only end up with 1 million attacking your DNA. So you have 1 million DNA alterations a day in each cell of your body. But those little beautiful stress proteins are there working every day, and they repair most of them. So you only have 100. And then your immune system comes in, and you end up with only about 1 on average. Get the picture? You're being bombarded. You're being bombarded by these reactive oxygen. You're being bombarded by stimuli which tend to break DNA, but you're being protected. Anything which diminishes the protective mechanism is a problem. Electromagnetic radiation diminishes prevention because it lowers melatonin, which is an antioxidant, and it lowers these stress proteins, which are also antioxidants. Electromagnetic radiation will also diminish repair if it's on every day. It diminishes the ability to repair. And finally, it diminishes the immune response, which protects you from any tumor that does tend to form. What's the effect of reducing your protective mechanism? You will have a higher probability of mutations. Instead of 1, you might have 2 every day. At the end of a year, you have 600. At the end of 10 years, you got 6,000. The point is, slight fiddling of your defense mechanism enhances the number of broken DNAs. This enhances the probability of cancer. This enhances the damage due to stroke. It enhances the effect of Alzheimer's because those same proteins remove the plaque as it's formed. It makes, at a heart attack, if you're being irradiated, it makes a heart attack more acute. If you have a heart attack, it's going to be worse. The last thing up there is an interesting point. Every day, if you continually use the cell phone, and you continually accumulate these broken DNAs, you are contributing to aging. That's what happens to you in life. As you get older, your DNA is much more defective than that of a 10-year-old. And the reason you get frail is you can't handle disease as well. In summary, everything's a question of dose. To protect the public health, we must determine the allowable dose for each of the above conditions. I'm no lawyer, but I do know this, that if you're going to preempt a piece of property, if the government is going to preempt it, and say, I can do what I want, maybe it has the right, because it's for the greater good, but it also has responsibility to know what it's doing to those who are around that preempted site. And preemption should not come before it fulfills its responsibility to understand what the effect of that site